you have two blocks, okay, of weight. One is 18 kg, the other one is 9 kg, okay, or mass in this case, okay, 18 kg and 9 kg. So each is connected by a cable or a string, okay, inextensible string. Okay, what happened when there's a motion? Okay, when it's moving, when it's in motion, you will see that the 9 kg of block will pull, okay, through the pulley. With the help of pulley, it's going to pull the 18 kg all the way down. When that happens, there will be a force that's acting downward, okay, due to gravity, which is W, okay, weight. So W equals to mg. So in this case, so mg will be 9 times by 10, okay, which is 90 newton. That will be acting downward. So if that's acts downward, so there will be another force that's acting upward, okay, which is the tension. And over here on this side, you have two forces resolving along the vertically or y-axis. You have one force that's acting downward. This is equal to the acting downward, okay. The force that's acting downward to keep it balanced is W equals to mg. In this case, 18 times by 10, which is 180 newton, okay, which is the W, okay, or the weight. And then upward force will be the normal force, okay, which is R, okay. So that'll be acting upward. So that's vertically. And then along the x-axis, which is horizontally, there is a motion. So if there's a motion, so we're going to use Newton's F equals to ma. The summation of the force is equal to mass times by the acceleration of the system, okay. So in this case, F equals to ma, and on your right there's a tension, so the tension will be working forward, and then this is equal to the backward forces, which is given as 0.5, so I've written here, okay. So now let's resolve the forces. Okay, what's happening at A? Okay, at A you can resolve horizontally. That will be T, the tension, okay. So horizontal force minus, okay, there's a frictional force that's acting opposite because of the surface is rough, okay. Frictional force, we know it's a force that's opposed the motion, okay. When there is a movement, okay, when we drive a car or whatever vehicle, there is a force that's acting opposite to our motion, okay, on the surface that we are driving, okay. That is known as frictional force, okay. So the rougher the surface, the more frictional force is going to be, okay. So that I need to take into account to find the summation of force or the net force. So to find the net force using Newton's second law, T minus the mu r. Why mu r? Because frictional force, okay. I don't want that. Once I minus that, what is left is what the net force, okay, and this is given by F equals to ma. So that's your net force, and this is equal to m. In this case is 18 times by a, okay, 18a, okay. So, and that's what happened on x-axis or horizontally, and vertically. So this is h, okay, horizontal. And then vertically, what's happening is you have R that's acting upward, which is the normal force, and then there's a weight that's acting downward. So R equals to 180 Newton, okay, 180 Newton. So and we know how do we find R? R is excuse me, it's given over here. So now let's sub this. So T minus mu R equals to 18a, okay, and then T minus 180 mu equals to 18a, and T equals to 18a plus 180 mu, and a is given as 0.5, so you sub that, so t equals to 18 times 1 over 2 plus 180 mu, so t equals to 9 plus 180 mu. Okay, so this is your first equation. And then at B, what's happening at B? Okay, at B there's no horizontal force, okay, because it's just a weight that's dangling downwards, just moving downwards. So if it's moving downwards, so M1 or mg over here, which is the W, minus the tension of the string or the cable, that will give you the net force MA. Okay, that will give you the net force MA. So W in this case, which is 90 Newton, minus the tension of the cable, that will give you 9 times by A, which is 0.5. Okay, so 9T minus T equals to 4.5. So T equals to 90 minus 4.5, and the answer is 85.5 Newton. Okay. Okay, next. I've got that. I still have one more thing to find, which is the mu. So to find mu, I just have to take these values, sub into equation 1. So this is, let's say it's 2 into 1. So 85.5 equals to 9 plus 180 mu. So 85.5 minus 9 equals to 180 mu. So mu equals to 85.5 minus 9 divided by 180, and I'm getting as 0.425. 0.425.